Welcome to this web lecture about the role and design of prototypes. The designer of the Palm Pilot started with a piece of wood as an early mock-up to get the impression what it is like to walk around with the modern equivalent would be the iPhone, to walk around with that and take notes with a stylus just to experience what it's like without having any functionality. Now, to experience a little bit more of the interaction, we slowly go from mock-up to product, first through perhaps sketches or series of sketches, later a storyboard or video that shows more of the interaction but doesn't give you the opportunity to actually intervene and to make choices. So a good alternative is to use either a PowerPoint slideshow or maybe a website. Both PowerPoint and website give you the opportunity to interact, to have different links or buttons you can click on that move to different parts of that slideshow. It can also be later a piece of software with some limited functionality. Typically this is written in a language for rapid prototyping, but it can also be written already in the target language, the programming language that will be used for the final product. Why do we develop prototypes? Some people would even say, why are we wasting our time on prototypes that do not really look and feel like the finished product when we could be working on the actual product? Isn't this a waste of time? The main reason for prototyping is to make it possible to do evaluation and get feedback about the design without a lot of development effort. Stakeholders, like management also, and possible clients, can already see, hold, and interact with a prototype long before the product is ready. And it's better to experience some interactive prototype than to read documentation. Writing the documentation is also part of the early phases of the development, but they don't give you the feel of interaction. You can also communicate with each other about the functionality and the interaction in the prototypes and make choices, test out ideas, check out different possible alternatives so that you can reflect on the design, really consider whether a choice that you made is a good one or a bad one, but without being too much concerned with the effort that already went into the development. The more effort you put into something, the less likely you are to actually throw it away when it turns out to be a bad idea. Prototypes typically answer questions. Is something a good idea? You let someone play with it and you find out. If you have several choices, and then a prototype allows you to pick out the best alternative based on feedback from the users. Early prototypes are typically low fidelity. They do not really look and feel like the final product. They can be paper or cardboard, they can be sketches on a whiteboard, or they can be done with post-its, anything that can be done quickly and cheaply. Special software environments for such rapid prototyping exist and are used a lot for early prototypes. Examples, right? Sketches on screens, maybe post-its that you put on a whiteboard, or special storyboard software that is used. I took this picture a few years ago at an art exhibition in the main building of our university. So this wasn't intended as a mock-up or prototype, but it could well function as one. If you're designing a new desk-side computer, you want to give your users a first-hand experience of what will be the size, what will it look like, what will be inside, what will it sound like, what's the experience of having this in your office. There is no real functionality inside this, but there are fans that are installed that you can already see in the picture, and the fans were running so that you could hear what the computer will be like. Later, we start developing high-fidelity prototypes. They use materials just like those in the final product, and maybe even already parts that will end up in the final product. So such a prototype looks much more like the final system than the low-fidelity version. For high-fidelity software prototypes, different development software exists. We can do it, for instance, in HTML5, a rich version of HTML to create very interactive websites. We can use Macromedia Flash or use Java as a development environment. Some of these can also be used for developing an actual product. There is a danger with such prototypes, especially when you show it to management, because the better the prototype resembles what the actual finished product should be like, the more likely management is going to think that you're actually done with the development of the product. It's a very bad idea to bring prototypes to the market before they have been finished as a product. We've seen too many examples of this already. When Microsoft first launched Microsoft Office, they had thrown together Word and PowerPoint and Excel that came from different sources. They were not well integrated. They were inconsistent in their interface. They were together not more than a high-fidelity prototype. They were not ready to be called a finished product. There are compromises in prototypes. The inconsistency I just mentioned is just one of them. Prototypes differ from the final product. They may be slower, the graphics may not be refined, and they may focus either on overall impression or on some parts of the functionality. A horizontal prototype focuses on the overall impression. A lot of functions are implemented, but perhaps incompletely. In a vertical prototype, a few functions that you want to evaluate have been really developed, but the rest of the interface may be either missing or have very crude prototypes. When you evaluate such a prototype, you will not get results that carry over completely to the final product. For instance, as we discussed in the evaluation part of this course, when a user makes a mistake, presses on a button that would normally activate a completely different function than he has in mind, but in your prototype that function has not yet been implemented, we can provide the user with an error message that says, sorry, this functionality doesn't exist. But we don't know how the user would actually have recovered from executing the function that is currently still missing and that wouldn't have been the one that he wanted to execute. A very special kind of prototyping is the Wizard of Oz prototyping. This is done in early designs when part of the functionality really needed for a prototype is very expensive. So what we do is we replace the computer by a human to produce the output instead of the computer. In early designs, this is done like shown in this picture. The user is interacting with what looks like the system, but in reality there is someone else sitting behind the curtain who is pretending to be the computer. This was done, for instance, to check how people would react to voice input to a computer. Users would give commands to the computer, hoping that the computer would interpret them correctly. Now, behind the curtain was someone who is listening, and when the user's command is clear, he would type it in, the computer would execute the functionality, which the user would then see. If the user's command wasn't clear, the expert behind the curtain would just type in some garbage, the computer would react in the wrong way, and we would see how the user reacts to his voice input not being properly recognized. If the experience is good, then we can start investing lots of money into developing the actual speech recognition. And if the experience is bad, we haven't wasted a lot of money on this development. Now, after prototypes have been developed, they need to be turned into real products. So we take our experience from the evaluations of the prototype. There may be actually several prototypes. We combine the experience and the different parts, and we create a whole. In this process, there are a number of quality issues to still take into account. The usability of putting things together may still need to be improved. The reliability may still not be perfect in a prototype. It may not be completely robust. It may also not be portable. For instance, we may have developed something on one platform that we actually want to market on many different platforms, but the prototype only works on one. Now, there's two ways in which we can go from prototype to product. In evolutionary prototyping, we take the prototype, which is developed in the target language, in the same programming environment that we will have for the finished product, and we add the missing functionality. We improve the functionality and perhaps efficiency of the parts that aren't yet refined, and so it evolves into the product. In throwaway prototyping, we throw away the prototype. This is, for instance, done when we used a rapid prototyping environment, and we came up with something that works as a quick hack, but not developed in the target language. So we have to actually redevelop, reprogram everything that was done before. To give you a rough impression of what this is like, you have a choice for your final product, for your final project, to either use HTML5, which is typically used for prototyping, but which is nowadays also sometimes used for actual finished products, especially for mobile devices. But the idea is essentially that you take sort of a web interface for your prototype and later redevelop it in a real programming environment. So a prototype designed in HTML5 very often turns out to be a throwaway prototype. The other option you have is to use the Java for Android environment. Now, when you use this environment, this is the actual target language that is used for many Android applications. So your prototype could be further developed using evolutionary prototyping into the final product without throwing away everything that you've done for the project. These are the choices you have, and choose wisely. But fortunately, for your project, it doesn't matter too much, as it will just stay a prototype. Thank you for participating.